So what shall we compare this series to? Well, it does have an n in the denominator, and one of the easiest and most famous series is 1 over n, and this diverges. So as you add up the terms all the way to infinity, that's going to add up to infinity. Well, this one is slightly more complicated because it has e to the 1 over n. Well, e to the 1 over n means that it's a root. So if you have 2, that would mean the square root of e. So don't be confused by thinking that means invert the e and put it in the bottom. That just means like you're going to have the square root of e, the third root of e, the fourth root of e. So what do those things look like? Well, if you have e to the 1 divided by 2, a 1.69, okay, what about a 3? So you're getting 1 point something. So that means that this e is producing something that's bigger than 1. That means if the numerator is bigger than 1, then this one is actually bigger than this one. Because this one only has a 1 in the numerator, not a 1.6 or a 1.3, etc. So that means the one we're given is actually bigger than this one, and this one goes to infinity, so that one has to go to infinity. So my guess is that it's going to be diverge. So then we have to compare and show. Is the sequence we're given bigger than or equal to one that we know diverges? By the way, if it was something you thought converges, then you would have to show that it's less than or equal to something you know converges. So when you're proving diverge, you show it's bigger than or equal to something that diverges. If it's converge, you'll do the opposite. You'll show that it's less than or equal to something that you know converges. In here, I think it diverges, so let's do the algebra. Well, easy enough, you can multiply by n on both sides, and then take the natural log. So natural log of 1 is 0. So in other words, as long as this fraction is positive, you're in business. Well, notice that n is 1 to infinity, so n is always positive. 1 is always positive, so this has always got to be true. Since n is never going to be negative, this fraction can never be negative. So the inequality is always true, so that means that, therefore, the series that has n in the denominator in e to the 1 over n is bigger than or equal to the series that just has 1 over n. And so we just proved it does diverge.